Hey guys, welcome to my channel Harshiv Education, and today we are going to talk about top 5 Facebook coding interview questions. So Facebook has 3 coding rounds and they ask many questions, and I went through multiple sites like LeetCode, Glassdoor, Geek for Geeks, and I found these 5 had been asked many times by Facebook, like many times. And it has been asked in Amazon, Google and Microsoft as well, but the number of time it's been asked in Facebook is quite a lot, so that's why I thought I should make a video of these 5 questions. So if you're going for Facebook interview, these would be really important for you, or if you're going for any FANG interview, I would recommend that these 5 questions are really important and we should definitely know about these questions. So let's dive right into it. We'll be taking 5 questions. First, we'll take merge intervals and then find all in anagrams in a string, then add string, valid parenthesis, move zeros. So these are the 5 questions we'll be taking in this video, right? So let's get right into it. The first question is merge intervals. So what happens is in this question we'll be given an input of array of array, right? Array of array. It is like array, and inside array will have another array of 2 variables, 2 elements only. So it is like merge interval. So this define an interval. 1 3 is an interval, 2 6 is an interval, 8 10 is an interval of all the integer comes between 8 and 10, and 15 and 18 is an interval of 15, between 15 and 18. So the question is, we have to give output of the similar array of intervals, right, which are overlapping, right? So it over here it is overlapping actually. The input intervals will have some intervals which are overlapping. Let's say this 1 3, so the interval is 1 2 3, and then the other interval is 2 6, so interval is 2 4 5 6, right? So 2 comes between 1 and 3, so this is a overlapping interval, right? This one is an overlapping interval and we have to convert it into non-overlapping interval. So if you see over here, this 1 3 and 2 6, we have overlapped it, right? We have overlapped it and made it 1 6. And this 8 10 and 15 18 is not overlapping with any other intervals. It is independent, so we'll just insert it 8 10 and 15 18, right? So now this output is a non-overlapping intervals. This output is a non-overlapping intervals. So we will be given an array of array which is an overlapping intervals, right? And we have to convert it into a non-overlapping intervals, right? So very simple. It's the question is, you have to convert the overlapping interval to non-overlapping interval. Similarly, this question, if you see 1 4 and 4 5, 4 and 4 is definitely in both of these intervals, so we have to overlap it, right? So 1 and 5. So if it was 5 and 6 over here, then it wouldn't be overlapping. Then we will take it as, okay, this result is quite good, it is non-overlapping, but it is overlapping because 4 is available in both the intervals. So we will merge it. We'll merge these two and make it a non-overlapping interval. Okay, so this is what we have to do. So let's see how we can do it. We have an array which is overlapping and we have to convert it into non-overlapping. So what we will do, if you can see in simple terms, when it comes to your mind, what you will do is you will have to compare all of these, right, with each other, right? So while comparing, what do you compare, right? You have to compare if the next interval first element is smaller than the first interval last element. If it is, then it means that these two are overlapping, right? And then we will merge it. We'll merge these two, right? So this is what we are doing. So that's all. That's how we will do it. We'll take an array of overlapping array. Okay, we call it overlapping array because we'll overlap these, whatever is overlapping will overlap and make it one array, right? So we'll do a loop through all of these elements and see if it is overlapping. We will update the one which is already there. So first we'll do a for loop on this. We'll take 1 and 3. There is nothing in this overlapping array, right? So we'll just insert 1 and 3, this interval, in our overlapping array. So this is 1, 3, right? Now, the next one, when we loop through this one, 2, 6, we have to compare the last element in our overlapping array with this element, 2, 6, the current element. So how we compare it, as I said, the last element of this should be smaller than the first element of this. So if it is not small, so 3 is not small than 2, it means then these two are overlapping. So in that case, we would insert 2, 6, we will just update 1, 3, this one, the last overlapping, the last element in our overlapping array, will update this with our the current interval in our loop. So how do we update it? We'll just update the last element of our overlapping interval with this with the last element of the current element. So we'll have 1, 6 over here instead of 1, 3. So we'll convert this. We'll change this 3. We'll update this 3 with 6, and it will become one element. We won't insert 2, 6. So we'll remove 1, 3, and we'll add 1, 6. So this is what we'll insert in our array. Now the loop will go to 8 and 10. It will compare 6 is less than 8. It is valid, it's not overlapping. So we'll just insert this 8, 10 directly into our overlapping array. And then the next interval in the next loop will go to 15 and 18. 15 is greater than 10, 10 is less than 15, so it means it's not overlapping, and we will insert 15, 18 in this array. So we have our resulting array 1, 6, 8, 10 and 15, 18, which is a non-overlapping interval. Yeah, so much. Let's see the pseudocode. I won't be giving the complete code itself in any language because I know all of you are working on different language, but the pseudocode should help you writing any code, writing this and solution in any language, right? So let's see. So we'll have a function merge overlapping intervals. Input would be intervals, which would be array of array, as I said. Like this is an array of array, and then output also would be an array of array, right? Okay, so this comparing the last element with first element, this comparing will only work if this array is sorted by the first element. So that's what we have to do first. We have to convert this array. So in our example, it was already sorted. It is 1, 2, 8 and 15, so we don't have to worry about it. But if the input array is not sorted, then first we have to sort it. So sort the interval array by first element of each item. First element of each item, right? And then we will create an overlapping array. We'll initialize overlapping array to hold the resulting input. You can call it non-overlapping array because we are basically creating non-overlapping array. But yeah, because we were overlapping these, that's why I named it overlapping array. Right, and then we will go through each element in this array. We'll run a for loop on each element in this array, right? So for the current item in this array, we'll check if the last item in overlapping array. So for this item, there is nothing in the overlapping array. So we'll just simply add the current item in the overlapping array, this one. If so 1, 3, when it was already there for 2, 6, if the first element in the current item, so 2 is greater than overlapping array dot last item dot last element. So if it was greater than this 3, sorry, it would be less than 3. So the first element in this current item should be less than, if it is less than the last element in the overlapping item in last item, so we should be the 1, 3. If it is less than that, it means it is overlapping, not greater than, guys. I've written it wrong. So it is less than. So if it is less than, then we'll just update our last item in the current overlapping array. So the last item in the overlapping array would be updated with this current item last element. So the last item would be 3, so this would be updated with 6. So we'll make it one array and it will become 1, 6, right? So we'll do the same thing as we did. So next it will go to 810. 810 is not overlapping anywhere, so we'll simply insert 810. 1518 not overlapping anywhere, we'll simply insert 1518. So that's how we do merge intervals. Let's go to next question. The next question is find all anagrams in a string. So what is anagram? It is like if you have a string ABC, the anagram of the string would be BCA, BAC. Like it should be a string which has similar characters, and the frequency of those characters should be similar to the string, right? So what it's saying is we have a string input array. We have in input we have two strings. One is this S, this long string, and then one this is P, right? So this P, we have to return an array of indexes of this P array wherever we find an anagram of this P. So ABC, so let's say CBA is an anagram of ABC because it has similar number of characters, same characters, and the frequency is also same, CBA and ABC. So we will insert index 0 because at index 0 we are getting an anagram, right? And then similarly at index 6, see, BAC is also an anagram of ABC, so that's why we have inserted 6. Whereas ACD, this last one, which is index 7, is not an anagram of ABC because D is not present over here, and in this ACD, D is not present, so that's why that is not an anagram. So we have not inserted 7 or any other indexes. So only 0 and 6 is the indexes where we are finding anagram in this array. Similarly, AB, we have input PAB. For AB we have to check, so AB is an anagram of AB, so at index 0. BA is also anagram of AB, so at index 1, and AB again we get AB at index 2, right? So 0, 1, 2, at all these indexes we are getting anagram of AB, so that is our resulting output. So let's see, how do we do it? So an input we have two strings, and in output we are returning the indexes of the anagram found in this string, right? So how do we do it? So this question will be doing with a concept of sliding window. How do we do it? I'll tell you. So we'll take two hash tables. So first hash table would be P hash table, which will have character, all these character and its frequency count. So for B we have, it is counted 1 only, the frequency count is 1, C is frequency count is 1, and A is frequency count of 1, right? So we'll have a hash table with key value. Key would be our character and value will be the frequency count, right? And then we'll have a P count. We'll keep a P count with the count of elements which is available in our P variable, right? So this P count will consider this as our window size. So in sliding window concept, you need to have a window size. So in normal concept, what we do, right? We just loop through all of these elements. So instead of looping through each element, we'll be looping through a window. So P count is 3. So for the window of 3, we'll be looping through these elements. So we'll be comparing first 3 characters of this array with this P, ABC, and we'll see if it is anagram or not. After that, in the next loop, we'll discard the C and then we'll go to next 3 characters. So we'll check if the next 3 characters is anagram of this ABC or not. If it is not, we'll not add it into our index array. If it is, we'll add it into our index array, right? Similarly, we'll just loop through this whole string with a window of 3. Right, we won't be looping through each character by character because we can't compare character. We have to compare a string of 3 because our P is ABC, which is of count 3, right? So for that, we will take one more hash table, right? Hash table S, which will hold first 3 characters. Not first 3, the 3 characters from this array, right? We'll be looping through this array and it will hold the 3 character from this array, and then in the next loop it will again hold next 3 characters and discard the last one, right? So in this S table, for first CBA would be inserted. So we'll insert BCA, and all this frequency count is similar to this one, right? So we'll have a resulting array, we'll keep a resulting array, and if this S hash table and P hash table is equal, if both these hash tables are equal, then we will insert this index. It is at index 0, so we'll insert index 0 in our resulting array, right? In the next loop, the sliding window will slide from C to B, and we'll have this window of BAE. So we'll remove the C from our hash table, we'll remove the C, and we will insert E over here, right? So now the next sliding window, the next window would have BAE. So if this S hash table is equal to P hash table, so it is not equal to P hash table, then we'll not insert this index 1 in our array. Similarly, we'll be sliding through all these, and when we'll reach this BAC, which is at index 6, then again our frequency count tables will be matching, and we'll insert result array, will insert 6, right? And once our table has reached this endpoint, right, then we'll stop and we'll say that, okay, yeah, in the result array we have our solution. So this is our solution 0, 6. That's how we do it. As simple as that. So yeah, so the let's see the pseudocode. We have find anagrams, string S, string P, the input, and then output is an integer array, right? So we'll initialize 2 hash table, P hash table and S hash table, which will hold character and frequency count, right? And then we have result array, which will be array of integer, right, to hold the result output. And then we'll have P count to hold the count of P string, which will be our window size in the sliding window concept. And then in some programming language, we cannot loop through these strings, so you can convert your string to an array. So I have converted like S array. I have an array of strings, S array, which will convert each string of this S string, right? So first what we do, we update our P hash table with this P characters of this P string. So we'll loop through the P string for each character, and we will insert the character with their frequency count like A, B, C in the P hash table. And then we will loop through this whole array, S array, right? And then similarly we'll be inserting a CBA in this S table, and as soon as the index has reached to the P count is 3, right? As soon as it has reached to the P count, what we will do is we will so once it has reached the P count, in the next loop it has to go to the next window, right? And C has to be removed, the last character has to be removed. So for removing the character, we'll get the first character from our S array, which is already there, and we'll check its frequency count. If its frequency count is greater than 1, then we'll just decrement the frequency count. And if its frequency count is 1, exactly 1, then we'll remove that character from the S table. Okay, so we won't just remove it, we'll check its frequency count. If it is greater than 1, we will decrement it. If it is less than, if it is equals to 1 or less than 1, then we'll just remove it from our S hash table itself. And in the end, we have to compare S table with S hash with P hash, both these dictionaries, or what do we call hash tables. We have to compare it. If it is equal, then we will just append those index. So in this the index we have reached to 3, so we'll deduct our P count from the index, and then plus 1 we'll get the first index, the C index, right? CBA. So we'll insert that index in our result array. So that's how we do it using the 2 hash tables and our sliding window concept for this find all anagrams. Let's look into the next question. Next question is add string. So instead of adding two numbers, the question is we are given two strings, right? Two strings, and we have to add these strings and return the output in string format only. So 11 and 1, 2, 3. If you add it, if you convert it into integer and add it, it would be 134, right? So, but the problem is you cannot use any built-in library for converting the string to integer. So that is the problem. You can't just convert it and add it and then convert it back to string. That's not how you can do it. It would become very simple. So the interviewer would want you to use your own logic to convert the string into an integer and then return it as string. You know, sum it and then return it as string. So how do we do it? We have two strings. We have to add it and return a string output, which is addition of these two string, right? So we will do it exactly the same way we do our integer addition. The only thing is we will loop. Obviously, we will loop through. We will be looping through the back from the backward. Like we'll have how do you loop, right? You have I and j, and if I is less than num1 count, j is less than num2 count, we'll keep we will keep looping through from the backward, right? So in the first loop we'll have 1 and 3 string, 3 and 1 string. So how do we convert these string into integer? First of all, then only we can add it. There's no way you can add two strings, right? So to do that, if you see we have this we can convert these into ASCII number. So if you see this table, character 0 ASCII number is 48, 1 ASCII number, character 1 ASCII number is 49. So using this ASCII number, we can get integer of these. So if you see character 0 has ASCII number of 48, right? So if character 3 can be deducted, if we deduct character 0 from character 3, so character 0 is 48 and character 3 is 51. So if we deduct the ASCII number of these two, we will get the number 3, right? So if we deduct from 3, if we deduct a character 0, we will get a number 3. So that's how we will do it. We will, for each character in our array, in our loop, we'll just deduct it from character 0 and we will get number 3. We will get our resulting number. So from 3, if we deduct 0, then we will get 3. From character 2, if we deduct character 0, we will get number 2. And from character 1, if we deduct character 0, then we will get number 1. So after deducting, once you have the integer, you will have to have a sum variable, and in that we will just, it is an integer, right? So after converting these two into an integer, we will add it. The addition would be 4, right? So how do we do the normal addition? We do carry forward also, right? Because if, let's say, if it was 8 and 8, so 8 and 8 is 16, so we can't have 16 directly, right? So we will have carry. So initially carry would be 0, and based on our sum, if it was 16, what we'll do, we will deduct the sum by 10, and then we will have our carry forward. So for, let's say, for our example 16, the carry would become 1, and the sum in the next loop, we will be adding this carry also in the next loop. So 1 and 2 will be 3 only, and we will add this sum, the carry forward as well, let's say 1. So it is exactly the same how we do our addition, the same thing, right? And in the resulting array, we will, so let's say sum divided by 10 is giving our carry, that would be 1, right? Let's say our sum is 16 instead of 4, because 4 doesn't have any carry forward. But sum mod 10 will give us the number which we want to have, which we want to add in our string, right? So sum mod 10, so in our example 1 and 6, the sum mod 10, 16 mod 10 will give you 6, right? So 6 plus the already resulted result which is already there. If result is already there, we will add it in the resulting array, right? So this is how we do it. In the each loop, we will check if carry is there. If carry is there, we will add it into sum, and to get the carry you have to deduct the sum by 10, and to get the actual number which has to be there, like 1 and 3, which is 4. So the we will check 4 mod 10 would be 4 only. If it was like some bigger number, 16 or something, then 16 mod 10 would be 6 and carry would be 1. So we'll do the carry forward and keep doing that. In this one, there is no carry, so 1 and 3 will give 4, right? And 4 mod 10 would be 4 only. So 4 plus result is nothing for now, so nothing. And then exactly in the same with 3, 1 and 2 would be 3, and then in the next loop we'll have 1. So it becomes 1, 3, 4, right? So this is how we will do our add string for addition of strings. So let's see this pseudocode. Initialize the result string to hold the end result, right? We'll have a result string. This is the result string which will hold the end result. We'll have carry initialized with 0, which will hold the carry forward, and then we'll have I and j. So how do you loop from the backward? You have to have I and j, which would be initialized with the I would be initialized with num1 count, and j would be initialized with num2 count, right? And as long as these two are not 0, we will keep on doing our thing. So what we do it in the loop, we will have sum, and in the sum, if I is greater than 0, we have to identify if I is greater than 0 or not. If I is greater than 0, then in num1 the character will take, and we will convert it into integer by deducting character 0 from this character 1. So once we have that, we'll just add that character into our sum. Similarly, we will do for num2 also with j. We will deduct character 0 from 3, and we will add that number 3 in our sum, right? Once we have these two, if there is any carry, if carry is not 0, if carry is there, then we will add the carry also to our sum, and then we'll update carry by dividing it from 10, right? And then we'll update our result also if with sum mod 10 and plus result if there is any, if it was already there in for the next loops, right? And we should be handling one edge case also, if, because let's say I and j both has reached the end and carry was not included. So we have reached to the end and carry was not included in the sum. So if it is not done, then if I and j has both 0 and carry is greater than 0, then we will add in this result array, we will just add our carry as well in the front of the result array. So this will give our final result, the sum of the two strings. Hope that's understandable. Let's get into the next question. The next question is valid parenthesis. This is my favorite question. I had been asked this question in Microsoft. I haven't given a Facebook interview, but this has been asked on Facebook as well for quite more times. As people have logged it into Glassdoor and Geeks for Geeks. So let's see. So what happens in this question? Will be given parenthesis. Will be given a string with parenthesis, and we have to see if it is valid parenthesis or not. Valid parenthesis means it has to be the opening bracket should be satisfying the closing bracket. So open bracket must be closed by the same type of brackets. So this must be closed by this type of bracket, this must be closed by this type of bracket, and this must be closed by this type of bracket. And the open brackets must be closed in the correct order, right? So this is true. So the output would be true and false only if whether the parenthesis was valid or not, right? So this is also true. Over here, if you see, this opening bracket is closed by this brackets, right? So this has to be closed by this one only. And this is being closed by this one, so it does not satisfy. It is not a valid parenthesis, so we return false. How do we do it? This is very simple. We do it using a stack, right? So we have this parenthesis, and result of this is of course true. How do we reach it? We will have a valid parenthesis hash table first of all, and this valid parenthesis hash table will have dictionary of key and value. Key would be the parenthesis. This is the resulting one. The opening one should this type of so we'll just define the type with the type of open and close which is valid in this valid parenthesis hash table, right? So for this one, this is the valid one, for this one, this is the valid one, and for this one, this is valid one. So we have kept it as key value. So for key would be the open bracket and value would be the close bracket. So we'll use this valid parenthesis table to check in our stack if it is valid or not, right? So we will have a stack, right, and we'll loop through each of these and we'll push. So every time we encounter an open parenthesis, we will push that into our stack. We will push it in the stack. And every time we have a close parenthesis, we will check it. We will peek in the stack and check if the last input, if the last parenthesis in the stack is valid for the closing one, the next one. So every time we have a closing parenthesis, we will check it with the last element in the stack, with the last pushed element. So this is satisfying. The closing one is satisfying the opening one. So if it is satisfying, how do we check it? We will check it in this valid parenthesis table, right? So for this closing one, we will go to our valid parenthesis and we'll say, okay, what is the valid opening one? So if it is valid, then we will remove the last which is valid. We will remove it from our stack and it will become empty, right? So similarly, we will do the same thing for this one. Every time we see opening, we will add it, and then for closing one, we will check the last element in our stack. If it is valid, we'll check if it is valid in the valid parenthesis table. If it is yes, it is valid, then we will remove it from our stack. Again, for this one, in the end, after this loop is over, we'll check if stack is empty or not. If it is not empty, then it will return false. In our case, if it is empty because we have a valid parenthesis, then we will return true. So let's see how it works. So we will have a stack array, right, which is of type string. Of course, our input is string and a string of parentheses, and output is boolean, right? We will initialize a stack array of string, and then we will initialize a valid dictionary hash table with key as opening bracket and value as closing bracket. And we will have one edge case. So if s count, the string count, is less than or equals to 1, it means we don't have much parentheses to be tested. Only one parenthesis is there. So if only one is there, it means it is not valid parenthesis, because there has to be two parentheses in your string, then only it can be valid, right? The pair, then only we can check the pair. So we'll return false. So for each character in string, we will run a loop, right? And we will check as what we were doing. For the character, we'll check if it is opening bracket. So if it is opening bracket, we will just append it in our stack. We will push it in our stack. So if it is opening bracket, we will push it. If the character is closing bracket, then we will peek the, we'll check if this stack is empty. So if it is closing bracket and stack is empty, then we'll return false, because we have encountered a string which has closing bracket first coming into our stack, which doesn't have any opening brackets, right? So we'll return false. That is a giveaway that, okay, your string is not valid, right away we'll say. If the last if the stack is not empty, it has something, and the last, then we will check the last character in the stack, right? And we will get the valid closing bracket of this last character. So the last character would be an opening bracket only. So we will check the valid closing bracket of this last character in the stack, and we will compare it with the current closing bracket. If it is equal, then we will pop we'll pop the last item in the stack, right? So we'll remove it. Yes, so valid closing for index last opening brackets, for hash table valid dex, so valid closing we get. And if valid closing, the valid closing one is equal to the current char, which is again a closing bracket for this one. So if it is equal, then we will remove the last opening characters from the stack. If it is not equal, then again, if it's not equal, then it means it's not a valid parenthesis, and we will return false. In the end, we will check if stack is empty. If stack is empty, then we'll return true. I should have written true over here. Else we'll return false in any other situation. So this is valid parenthesis. Let's move to our last question. This is move zeros. This is very important question, guys. It has been asked by Facebook many times, like many times. If you see Glassdoor, every other person has been asked this question. The question is very simple. We have a array and we have to move all the zeros to the end of the array, right? To the end of this array. So we'll just move, so 0 is here. We'll add it to the end. If array has only 0, then it will return 0 only. Quite obvious. So this is very simple question. We'll be given an array with zeros and we just have to move the zeros to the end of the array. How do we do it? We will have two pointers, first and second. First would be at index 0 and second would also be at index 0. So how do we do it? We will move, in each loop we'll be moving the second pointer. So if item at index second is 0, so if item at index second is 0, then so if it is 0, if it is true, then we'll just move the second to the next pointer. So we'll just do second equals to 1 plus, right? So in our array, item at second index 0 is 0 only. So I'm sorry, I'm babbling. So second is at index 0, right? So item at index second is 0 only. It is 0, right? Then we'll just move the second index to the next item. So now our first index is 0 and second index is 1, right? Now if item at second index is not 0, if it is not 0, then we will swap the item at first index and second index. So if it is not 0, we'll swap the item at first index and second index. So 1 will move over here and 0 will move over here. Then again we will check if item at index second is 0, then we will move to next index, and then first would be here only, and then we'll keep comparing. Second will be moving forward from the first index. First will be behind second, right? And every time we encounter that item at index second is not 0, then we will swap it with the item at index first. That's all we do. So move 0, if num count is less than 1, will return the input array itself, because it doesn't make sense. It has to be more than one element in the array, in the input array, then only we can move to 0, right? And then we will initialize first and second pointer. And if second pointer is less than nums.count, as I said, second would be moving forward and first would be at behind second only, right? So if item at index second is 0, then we'll skip to the next index in second. Second will be incremented by 1, right? We'll skip the item for second index. And if it is not 0, then we will swap the first and second index item and we'll increment our first and second item both, right? So if you loop through this, for initially first and second both would be pointing to this. We'll check if second index item is 0. It is 0, so we will move the second to 1 to here. So second will become 1 and first will become 0. We will overlap it and then we will increment both these. So second will move to here and first will move to this pointer at the first. So first would be 1 and second would be 2, pointing to this. Now we'll check if second pointer is referring to 0 only. It is referring to 0. Then we'll skip the second also, we'll increment the second to this one. So now second will become 0, 1, 2, 3, index 3, and first would be at index 1 only. So at index 1 we have 0. Remember we had swapped it, right? So index 1 we have 0 and index 3 we have 3. So we'll swap again. So 0 will come here and 3 will come here. So similarly it will again move, and after that we'll move again the 3, it will become 4, second will become 4, and first will go to this array, this element, which will again be 0, and then we'll swap again. So 1, 3 and 12 will come here, and 0, 0 will move to here by swapping these first and second in pointer elements. So that's all. That's the all 5 questions which are very important for Facebook coding interview question, for coding interview rounds. So yeah, so that's all. Thank you so much. If you like this video, please do subscribe, like, comment, and share with your friends. Thank you so much for watching, and I'll be coming soon with more coding interview questions for FANG companies and any other companies which are very important questions. Thank you. Bye bye.